So let's now look at the junction between the smallest subnormal number and an underflow to 0 plus. So the smallest subnormal number is going to be given by 7 zeros and a 1 in hex. And I've written that number up here. So it's all zeros apart from the 32nd bit, which is a value of 1. So let's go ahead and we'll put this number into our conversion tool. So let's put that value into the converter here. We know that the exponent is all zeros because it's going to be a subnormal number, and the value of the mantissa is the smallest value for the mantissa, which is a value of 1. So we can see here that because it's a subnormal number, we define the exponent value always to be 2 to the minus 126. So that means that we've moved down to a window that's very, very close to 0. And now what we want to do is choose the subnormal number that is the smallest. We want to choose the mantissa, which is the smallest value, and this will give us our smallest subnormal number. So the smallest value then is this value of 1 in the final bit. So you can see here that we're going to have our minus 126, which is our subnormal or denormal number. So we've got 2 to the minus 126. And you can see here that the mantissa has only got a value of 1. So this is the value of 2 to the minus 23. And this is a 2 to the minus 23 here. And you can see it's e to the minus 7. So you can see that our final result here then is going to be our 2 to the minus 126. We'll have our mantissa, and our mantissa for a subnormal number we add on the 0, and we also have our sign bit here, so it's a plus value, so it's a positive value. So when we multiply these together, we're going to get the smallest subnormal number, and that's this number here. So now if we try to get a number that's smaller than that, you see that if we make this 0, then it's just going to tend towards 0, and we'll just get a value of 0. So this is us underflowing to 0 plus. So that's the smallest number and underflowing to 0 plus. So let's have a little look at this number in more detail. So the smallest subnormal number is given by 7 zeros and a 1 in hex, and we've seen that number above here. It's the 32 bits with a single 1 at the end. So this number is going to be the exponent value times the mantissa value. Now the exponent value gives us the window that's closest to 0, so that's a power of 2, which is minus 126. And we're multiplying that by the smallest mantissa value, which is 2 to the minus 23. So whenever we multiply these, we add the indices. So that's equivalent to 2 to the minus 149. And 2 to the minus 149 in decimal is approximately equal to this number here, 1.4012984643242 e to the minus 45. Of course that number just continues on, and it's just this is just an approximation. So let's look at this number mathematically. If we say that the radix is a value of 2 and we call the radix beta, then for the exponent we're going to have beta to the minimum exponent, which is minus 126, and we're going to multiply it by 2 to the minus 23. So again we're multiplying it by beta, and it's raised to the power. Now the power is going to be again 1 minus p, where p is the length of the mantissa including the hidden bit. So including the hidden bit, the mantissa is going to be 24 bits long. So it's going to be 1 minus the 24, which gives us the minus 23. So again, whenever you multiply, we can add the indices. So that's equivalent to beta times E min plus 1 minus p. So this number here is going to be the smallest subnormal number. So thank you for listening. I'll get you in the next video. Goodbye.